Okay, and we had a couple of questions from workshop 4 in lesson 4.5, so let's take a look at those. All right, let's start here, section 4.5, number 17. We want to solve the inequality of x squared minus x plus 1 is less than or equal to 0. So with that information, since it's already set equal to 0 or less than or equal to 0, we can identify our a, b, and c. A is 1, b is negative 1, and c is positive 1. So we'll use that information to find our vertex. So we'll start off by finding the x coordinate of the vertex by using this formula, x equals negative b over 2a. Okay, so x equals, again, b is negative 1, so we have negative times negative 1 over 2a, so over 2 times 1. So x equals positive 1 over 2. So the x coordinate is 1/2. Now we're going to take this 1/2 and plug it back into x squared minus x plus 1 in order to find out the y coordinate that goes along with this for the vertex. Okay, so number 17, let's find the y value that goes along with this under the vertex. All right, so we had, again, x squared minus x plus 1. So let's say y equals x squared minus x plus 1. And we know that x is 1/2 from the value that we just found. So we're trying to find the y that goes along with it when x is equal to 1/2. So that gives us 1/4 minus, let's go ahead and make that 2/4. Let's go ahead and make that 4/4. So we'll have a common denominator all the way across. So 1 minus 2 is negative 1, and negative 1 plus 4 is positive 3. So my vertex is 1/2 or 0.5 and 3/4. So that tells me where the bottom point of my graph is, and we know this graph is going to open upwards because the coefficient on x squared is positive. All right, so now with that information, let's keep that in mind, and let's find the x-intercepts. If there are some, let's find the x-intercepts. And we can go ahead and find the y-intercept on this one right quickly. Y-intercept is when y equals, x will be equal to 0, so y equals 0 squared minus 0 plus 1. So the y-intercept is 0, 1. Okay, let's find the x-intercepts. We'll use the quadratic formula to find the zeros or the x-intercept. So we have x equals, remember that your a is 1, b is negative 1, and c is 1. So x equals negative times negative 1 plus or minus negative 1 squared minus 4 times 1 times 1, or times negative 1 times 1, all over 2 times 1. So calculations. And here you have 1 squared, and then negative 4 times 1 is, sorry, that should have been a positive 1. I had that correct first. Negative 4 times 1 is negative 4. So 1 minus 4 is negative 3. 2 times 1 is 2. So since we have that negative underneath our radical, we should know that our roots are irrational, imaginary. So the square root of negative 3 is I times the square root of 3. So that's an imaginary root there. So what that tells me is that we don't have any x-intercepts. This graph will not touch the x-axis since we didn't have a real intercept here. We had that imaginary number. Okay, so let's take a look at this graph. We found that the x-intercept was -1/2 or +1/2 and 3/4, so about right there. Sorry, the vertex was 1/2 and 3/4, so about right there. We found that our y-intercept was right at about 1, so right in there. But as you see, that this graph never touches the x-axis. So therefore, our solution is no solution because it does not intersect the x-axis. So we don't know, the function will never be less than 0. We don't have those zeros to determine whether the function will be less than 0. So again, since it does not intersect the x-axis, we cannot determine uh, where the function will be less than 0. So that should really be no real solutions. No real solutions. Okay, so now the next problem is a little bit different, but kind of the same. Number 17, I think we had a question on. I think that was number 21. Okay, all right, so with this one, on number 21, same section, we had 6 times the difference of x squared and 1 is greater than 5x. So first thing we want to do is use our distributive property, 6 times x squared, 6x squared, 6 times -1 is -6, and bring this 5x over to the left-hand side by subtracting. So that gives us 6x squared minus 5x minus 6 is greater than 0. So we want to find the solutions for that inequality. All right, so go back through the same steps. Identify your A, B, and C. Plug them in to find your vertex. Find your x-coordinate of your vertex. So that gives us 5/6. 5/12, sorry about that. Then we're going to take that 5/12, plug it back in to find the y-coordinates of the vertex. So again, calculations. So if you're using a calculator, that's fine. So we would have y equals 6x squared minus 5x minus 6. And in this case, x is equal to 5/12. So this problem is a lot about the calculations. Okay, so 5/12 squared is 25/144. 5 times 5/12, 25/12. All right. I think you can simplify this a little bit. 6 will go into 144 24 times. So that gives us 25/24. Let's get a common denominator, minus 50/24. And then 24 144/24. Okay, so that gives us -169/24, and it may help us to look at that in the decimal form, which is about -7.04. So now we have the vertex of 5/12 or 0.42 and -169/24 or -7.04. That may help us to graph that, get a little bit closer with graphing that point. All right, so now that we have the vertex, we can go ahead and find the x and the y-intercepts. So again, the y-intercept is where you simply plug in 0 for x. So we have y equals 6 times 0 squared minus 5 times 0 minus 6, which tells me that my y-intercept is -6, or the point 0, -6. Then the x-intercept, we're going to use the quadratic formula again to find that x-intercept, or the x-intercept's probably more than one. Okay, so x equals negative times -5 plus or minus b squared, which is -5 squared, minus 4 times a times c times 6 times -6, all over 2 times 6. So calculate. So you have 25 minus 144, which gives you, or 25 plus 144, which gives you 169. And we have negative times negative, that's why that's plus, all over 12. So the square root of 169 is 13. So you have 5 plus 13 over 12. And then you have 5 minus 13 over 12. So it gives us 18 over 12, which simplifies to 3/2. And then it gives us -8 over 12, which simplifies to 2/3, negative. So those are my x-intercepts, 3/2 and -2/3. Okay, you can just pause that video if you need to right there. Let's look at the graph of it. So the vertex, 0.42, -7.04, right down there. The y-intercept, about -6, so right in there. Then the x-intercepts, right there and right there, -2/3 and 3/2. So we were looking for the values where the function was greater than 0. So if we look to the left of 2/3, that's where the function is greater than 0. So when x is less than -2/3, the function is greater than 0. Also, if we look to the right of 3/2, the function is greater than 0. So x will be greater than 3/2. All the x values that are greater than 3/2, that's where the function is greater than 0. Okay, I know that's a lot, but I hope that was helpful to you. All right, thank you.